Hey guys, it's me coming from your basement, from my basement again. A couple things I wanted to talk about. We are just going to pick up where we left off on, I guess it was last Thursday. First, hopefully you've been memorizing your polyatomic ions, knowing their names, their formulas, and their charges. You will still be having a quiz. I'm not sure exactly what that's going to look like, but it'll be this week. So make sure you know names, formulas, and charges of your polyatomic ions. We are continuing on where we left off on Thursday, which was we were looking at different types of chemical reactions. Specifically, your class had just finished synthesis reactions. You got a worksheet for homework. You hopefully were able to see the answers to those. And I would like to have a quiz on that stuff as well. So if you have any questions, or if you haven't even looked at it in a while, please take a look at that and be sure to send me a message or an email so I can answer whatever questions you have. But generally speaking, you know a synthesis reaction looks like what you see on the screen. That is, you have two or more reactants coming together to make only one compound. And that's the most simple type of synthesis reactions. Back in the beginning of the year, you actually did a lab where you did a synthesis reaction. That is, you took a piece of solid magnesium and you burned it, and you got that bright white light. That was magnesium reacting with oxygen to make magnesium oxide. The idea here is just that you're able to recognize that this is a synthesis reaction and to come up with a formula for the product as well as balance the equation. So those are synthesis reactions. Decomposition reactions are very much the opposite of a synthesis reaction, where instead of making one product, we are actually starting with one reactant. And you can see up here, one reactant, which is a compound, will break up into two or more simpler substances. Sometimes those simpler substances are plain old elements, and sometimes they are compounds. For example, you'll remember we did this lab recently where you took one reactant, that is baking soda, or sodium bicarbonate, and it broke up into, in this case, three simpler substances. For now, all you'll have to know for a decomposition reaction is to be able to pick one out if you see one. And again, they're very easy to pick out. They're the only type of reaction with one reactant. And this slide is just showing you how synthesis and decomposition reactions are reverse of each other. Next, we're going to move on to our third reaction type, which are our single replacement reactions. Sometimes they're called single displacement reactions. And you'll see from this picture, it's a pretty typical analogy of a couple dancing and a guy off to the side, tapping the one guy with the dark hair, tapping him on the shoulder, and taking his place, right? The guy with the red hair is taking the place of the guy with the dark hair. And so how does that relate to chemistry? Well, this guy with the red hair is supposed to symbolize an element. And this guy with the dark hair, because he's dancing with this woman, they are a compound. In a single replacement reaction, an element replaces a similar element that's part of a compound. Your products will always be then another single element and another compound. If you want to look at the technical definition, here it is. One element in a compound is replaced by another element. Notice it does say that these reactions have to take place in solution. That is, the compound has to be dissolved in an aqueous solution in order for the reaction to take place. And what I've done here, I just highlighted this example where A is replacing B. That is, it's taking its place. And sometimes people get confused and they put A with B, and that's not the case. Remember, the single guy tapped this guy on the shoulder and kind of kicked him out, right? So now B is by himself. The A is with a partner in a dance, or what have you. So the reason these are in blue, A represents a metal. A metal can replace another metal that's part of a compound. Likewise, if your free element is a non-metal, let's say like chlorine, chlorine can only replace other non-metals. So sometimes you'll see in a single replacement reaction It's actually the second element in the compound that gets replaced. You're not going to need to come up with the products for these single replacement reactions. You'll just need to be able to recognize the fact that we're dealing with a single replacement reaction. You've done some single replacement reactions in lab. One of the first labs you did with me is we looked at what happens if you put aluminum foil in a solution of copper nitrate. And you started off with a nice clear blue copper nitrate solution. You put your shiny aluminum metal in there, and after you waited a couple minutes, you started to see two things happening. First, the blue solution turned clear. That is, the copper nitrate was no longer present. And you started to see this red solid develop on the aluminum foil. What happened? Oh, okay, well, the aluminum, let's see if I can draw on this one. Here we go. The aluminum took copper's place, right? So aluminum came in here, kicked out the copper, so the copper metal developed, and that's why you see it red right on that aluminum foil. That is solid copper. Aluminum takes copper's place, so now the aluminum is partnered with the nitrate. I know you can't see the rest of this because I'm blocking it, but it doesn't matter. You see what the general reaction looks like. Another more kind of vigorous reaction that we saw, let's see if I can hide this for a sec, is we took a piece of potassium as well as a piece of sodium for that matter, and I placed it in water, and we saw this really dramatic reaction. I had placed some phenolphthalein, which is an indicator solution, in the water. When the potassium went in, we saw a lot of flames. It was kind of popping, and it turned the water kind of a fuchsia color. Well, that's because we have this single replacement reaction between the potassium and the hydrogen. Potassium took hydrogen's place, so now we're making KOH. Potassium hydroxide is a base. That's why this turned pink in the indicator solution. And then now the hydrogen is going to be by itself. Hydrogen gas happens to be flammable, which is why we saw the flames develop there. So two examples of a single replacement reaction. And finally, our double replacement reactions are our fourth type of reaction. And what makes these different from single replacement is that, in fact, two things are getting replaced or exchanging places. In this analogy, we have this guy wearing green and this guy wearing blue. They're going to switch dance partners. So notice over here, they have new dance partners. How does this relate to chemical reactions? Well, these couples represent compounds. So in a double replacement reaction, you can see the cations of two compounds replace each other. Once again, there needs to be solutions here. That is AX and BY, whatever they are, they have to be dissolved in water. So the cations of two compounds. Let's go back. The first part of each compound switch places. So again, this guy in green is still the first thing in this compound. The guy in blue is still the first thing. They represent cations. Metals always get written first. Non-metals or anions are always written second. All right, let's see if I can show you an example of a double replacement reaction.
In the double displacement reaction of silver nitrate and sodium chloride, we have a solution of silver nitrate, which is colorless. We'll add a solution of sodium chloride, which is also colorless. When the sodium chloride solution is added to the silver nitrate solution, a white precipitate, insoluble silver chloride, is formed.
All right, so here is the equation that you just saw, where we're taking a silver nitrate solution, reacting it with a sodium chloride solution. What's happening here? Uh-oh. There's music going on. Okay, sorry about that. Anyway, let's try this again. The silver and the sodium switch places, right? So now the sodium is partnered with nitrate, and the Ag takes sodium's place in the front or the beginning of that equation, and you get silver chloride. For now, for today, all you have to do is be able to recognize a double replacement reaction. Tomorrow, we'll look at how to come up with the products yourself. That is, what are the formulas? How do you come up with the correct formulas? And how do you know that it's the AgCl that's the precipitate that we saw in that video? How do we know it's not sodium nitrate? But that's something for us to work on tomorrow. So guys, on Google Classroom, you're going to find a worksheet that will help you practice coming up with or identifying the 4 types of reactions. Answer key will be provided. And don't forget to study those polyatomic ions, all right? I'll talk to you guys tomorrow.